Today's lesson is going to be writing equations in two variables. It's lesson 7.4 on page 314. Our purpose is going to be to identify the independent and dependent variables in an equation with two variables and then to plot it on a coordinate graph. An equation in two variables represents two quantities that change in relationship to one another. A solution of an equation in two variables is an ordered pair that makes the equation true. So remember, an ordered pair is always going to have two numbers. They can be positive or negative, but it's essentially the set of numbers that you would go ahead and graph on a coordinate plane. Okay, now let's take a look at example 1. It says, tell whether the ordered pair is a solution to the equation. When I look at my first problem here, it says that y equals 2x. Now, what they want to know is the ordered pair 3, 6 a possible solution? You have to remember that the first number is always the x value. The second number in a coordinate pair is always the y value. So I'm going to substitute 3 and 6 in for my variables x and y. So that means the 6 is over here on the left for the y value, and 3 is the blue number substituted in for the x. Now, I have 6 equals 2 times 3. If I multiply 2 times 3, I get 6. So 3, 6 is a solution to this problem because 6 is equal to 6. Let's take a look at example B. This time, my ordered pair is 4, 12. And my equation is listed right in front of it. Y equals 4x minus 3. So we're going to take the ordered pair of 4, 12, substitute 4 for the x right here, and substitute 12 for the y. So, substituting my values in, I get 12 is equal to, and a question mark because we're not sure yet if it's true, 4 times 4 minus 3. 4 times 4 is 16. 16 minus 3 is 13. 12 is not equal to 13, so the ordered pair 4, 12 is not a solution. Now we're going to relate these terms to independent and dependent variables. Just like you've talked about in science, there are independent and dependent variables in science. The same is true for math. You can use equations in two variables to represent situations involving two related quantities. The variable representing the quantity that can change freely, I'm going to underline this, is the independent variable. The other variable is called the dependent variable because its value depends on the independent variable. Now, one thing I want to make sure that you understand is the independent variable will always go on the x-axis. The dependent variable will always be featured on the y-axis. I would like you to please pause this video and record our two definitions. The independent variable is the variable that is subject to choice and is not influenced by another variable. Once again, it is always going to appear on the x-axis. The dependent variable relies on the value of the independent variable, and it is always on the y-axis. Once again, please pause the video, record these definitions. We're now going to take a look at how this relates to tables, graphs, and equations. You can use tables and graphs to represent equations in two variables. The table and graph below represent the equation y equals x plus 2. So whatever our variable is, and here's our x, remember that the y, for the x, to get the y, we have to take the x and add to it. So for example, if our independent variable of x is 1, we have to add 2 to it, so that means y is going to equal 3. So my ordered pair is 1, 3. If my independent variable, or x value, is 2, I have to add 2 to it. 2 plus 2 is 4, so my ordered pair is 2, 4. And then finally, if the independent variable is 3, my dependent variable then becomes 3 plus 2 for my y value, which is 5. The ordered pair is 3, 5. Now you'll notice off to the side, they've graphed the line. This is really important because it relates back to the exact same thing that we were talking about when we had our chapter on ratios. Notice that if you've done this correctly, all of the values are going to fall into a straight line. Now that straight line doesn't necessarily have to pass through the origin down here. It may not pass through 0, 0, and that's okay. But all of them will fall into a straight line.